All right. So now I'm going to switch to kind of slides, and I don't want this one. And I'm going to actually keep it like this. So I'm not going to really go to presentation mode. There's no need because I'll be probably kind of going back and forth quite often. So as long as it's big enough, that's good. Okay. So this one converts -12 to 1's complement. We actually did that. It looks like this. You can verify that after this recording, but those slides actually have been posted. So you should be able to see at least up until this point. Here, there's another question. How does 20 look like in binary using 1's complement? Now, of course, 20 is positive. Can we fit 20 in 1 byte? Clearly, the answer is yes, because you have 7 bits, which 7 bits is way too many for 20. I mean, more than what you need. So 20 would be 16 plus 4 if you think about it. These are the powers of 2 that add up to 20. And it would be 1, 2, 4, 8, 16. So that would be this one. So again, you can look at this home. Maybe I shouldn't answer this one. I'll let you kind of think about it, and then I can post the slides. Think about it, and the answer is going to be on the next slide. Here I'm saying that we have 2 zeros in 1's complement. So in fact, I'm not talking about zeros quite yet. Here I'm talking about converting. So stuff that we did kind of here. Right now I'm converting this to decimal. Again, we look at the most significant bit. If it's 0, we just convert that to kind of unsigned. If it's a 1, we convert this one to unsigned, but then we give it the negative sign. So we actually did that. So I don't want to repeat all of that. I'll let you review that home if you need to. I'll post the slides. And for this one also, I'm not going to show you the answer. This is the range of both sign and magnitude and 1's complement. So we did kind of establish that in sign and magnitude. This is the range in 4 bits. In 1's complement, this is the range using 4 bits. But we still have the 2 representations of 0 problem. This is a problem. And we did talk about that. So we have the positive 0 and negative 0. Of course, the positive 0 and negative zeros look different in sign and magnitude, but in both representations, we have positive 0 and negative 0, which is unfortunate. Now let's talk about addition. Again, in sign and magnitude, we do have a problem making addition, doing addition. And let's see in 1's complement how that's gonna turn out to be. So this one is 4 in 1's complement, or unsigned, or sign and magnitude. It's a positive number, so it's going to be 4 regardless of the representation. This one's going to be -5 in 1's complement, right? Because we look at the most significant bit. That's the one we swap everything. We end up with 1, 0, 1, 0. That's going to be 5. We add the negative, so that's going to be -5. So this is 4, and this is -5. Now, if we add -5 to 4 in decimal, we end up with -1, right? 4 plus -5, or 4 minus 5, that's going to be -1. So -1 in 1's complement looks like this, right? If you don't believe me, I think you do believe me, but if someone else who's watching the video doesn't believe me, this is 1, and then I'm going to swap the zeros with 1s and 1s with zeros, and I end up with this. So this is really -1. So we want to hope that when we add this sequence to this sequence, we end up with this sequence. That's the hope. And of course, it doesn't take you long for you to kind of eyeball it and determine that this is the case. 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 0 plus 1, 1. So you end up with 0, 1, 1, 1. So in this case, addition actually did work, right? We were able to add -5 to 4, and we ended up with the correct representation, which is -1. Do you have any questions about this, or are you ready to proceed? Okay, so Grace is saying you cannot add two negative numbers, can you? Okay, that's a good question. Let me see what's on my second example. And if it's not adding two negative numbers, I'm going to come up with an example and we can do it together and see if adding two negative numbers is going to be okay or not in one's complement. Of course, in decimal, we can add two negative numbers. We can say -1 plus -2. That's allowed. We end up with -3. But in one's complement, is it allowed? That's the question. Let me see what my next example is. And then again, if that's not the case, I will this is all okay. So here you see I'm doing the addition. I'm telling you that this is the correct answer. Let's try this one. Okay, so my second example is actually not adding two negative numbers. So how about we create an example, and adding two negative numbers and see if it'll work. Let's do that. And that's a very good question, Grace. I'm gonna, what two negative numbers you want to add? As long as the answer can fit in the number of bits that we're adding, it's fair game. Just give me any two numbers, any two negative numbers, as long as adding them should result in a number that fits in 4 bits. -5 and -7 are not good numbers because if you add up -5 to -7, you end up with -12. -12 does not fit in 4 bits because the range of 4 bits is -7 and 7. Of course, we can use 5 bits, but let's stick to 4 bits for now. So I'm going to stick to 4 bits. Okay, that's good. So Grace is saying, how about we add -5 to -2, and we should end up with -7, and we should be able to represent -7 in one's complement. Why not? It's within the range. In fact, I'm going to start with that. -7 in one's complement is going to looks like, again, we start with 7. I'm going to do it the slow way, which is a good way. I think that's how you should do it. You start with 7 and then you swap the ones with zeros and zeros with ones. So that's good. That's -7. Now, how does -2 look like? Again, we're going to start with 2 and then we're going to swap. Are we happy with this? Let me do -5 and then I'll pause and see if you have any questions. So we start with 5 and then we swap. So it becomes 1 0 1 0. So this is -5. Do we have any questions about any of that? Okay. It seems that there's no questions. I'm going to add the 2. And what's going to happen is you're going to realize quickly that there's a problem. Let's go to text. Let's do bottom like that. So you're going to realize that there's a problem here really quickly. So let's try to do the addition. I can't zoom in more. But if you add 1, so let's do from right to left, of course. 1 plus 0, that's going to be 1. And that's automatically a problem, right? Not automatically, already a problem. That's what I should say. It's already a problem because this should be the answer that we would get. And adding the 2 least significant bits are going to give us 1. So we have a 1 here then, but let's continue. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, 0. And of course, there's a 1 that goes kind of outside of what we can represent, right? So there's a 1. Let me actually, this pages, as much as I like pages, which is a software, kind of Apple's kind of Word equivalent of Word. As much as I like it, sometimes it can be annoying. Okay, so now this is what we have. This is the result, and this is a problem, right? Now, of course, excuse me, of course, when you add, let me actually copy this and paste it here. I feel like Keynote is actually easier to do that kind of stuff. So these are the numbers. Let me actually copy the whole thing. Ah, it seems that I can't copy it. Let me try again. Okay, that's good. That's actually fine. That's okay. Let me copy this thing. Okay, that's actually not bad. And of course, the answer is going to be 1, 1, 1, and 0 here. So this is a new example. I'm going to say new example. I'm going to say participants example, because that's provided by Grace. Okay. So of course, like I said, we do have a 1. Let me make this the same font. We do have a 1 that's going to be probably here that we have to kind of just kind of throw away maybe, because we can't do anything with that one. So in summary, what's happening here is that adding -2 to -5 is not giving us the value that we want to get. And as a result, maybe, let me make this -2 so that I don't want to make it confusing here. And because of that, you might think that we cannot do addition or proper addition in one's complement. Now, I'm going to tell you that there is a way to make this addition correct. There is a way to make this addition, which looks really wrong, and it is wrong right now, to make it correct. So there is a way to make one's complement addition work. But let me look at the chat. I can see a few questions at least. So let me see. Oh, I didn't know you can reply in Zoom. Maybe that's a new thing where you can reply to folks in the chat window. Okay. So the question is, does the extra 1 mean we need to swap the ones and zeros in the answer? Okay. That's a good idea. It works this time. So what Anthony's saying, maybe the way we can make it work, because that's really what I'm alluding to. I'm saying there's a way to make it work, and Anthony and Grace right now, they're thinking, what could that be? And Anthony has a suggestion, and the suggestion is, or maybe the guess is, maybe when we have a 1 here, that's going to mean swap the zeros and ones that are here. And in this case, actually, it would work, because -7, as I mentioned earlier, as you already know, -7 is 1, 0, 0, 0. So what's happening here is, which I really like what you're doing here, guys, because this is very important in the learning process, is that you kind of think and try to guess, and then I'm going to come to you and tell you this is wrong or maybe right, and then you're going to kind of adjust. So this is a very important process that needs to take place whenever you're consuming knowledge, whether it's when you're reading a book or when you're watching a video. It's important that you kind of pause and think and guess, and whether you get it right or wrong, that's not really the point. but it has to be kind of interactive. So I'm happy that you're coming up with a suggestion. Okay, so that's the suggestion. Let me look at the chat. I think there's more messages that are going on here. Let me see. So Grace kind of likes the answer. Anthony thinks maybe he's thinking that may not work in every incident. Then there's a follow-up. Will this happen consistently when adding negative numbers to one's complement? Okay. So let me give you the answer, and let me tell you how we can make it work every single time. So the answer to the question, that is it the case that when we see a 1 here, we can just swap the ones with zeros and zeros with ones and that'll work? And the answer is no. It's actually not going to work every single time. This time it's working. It's not going to work next time when I change the numbers. However, the solution is actually similar to what you proposed, Anthony. It's not very different from what you proposed. But before I tell you what the answer is, I'm going to try to demonstrate for you that having a 1 here and then swapping the answer is not going to work every single time. So I'm going to say participant 1 example. And then I'm going to say participant 2 counter example. That's my example. I'm going to give you a counter example to your theory. Let's say, for example, -2 and negative, sure, -2 and -1. Or maybe I can do, I think that should actually do it. -2 is going to be the same. Let me get rid of, actually, let me put it, just hide it for a second. So -2 in one's complement is this. -1 in one's complement is, this is 1. And then I'm going to do 1, 1, 1, 0. Are we, let me kind of get a thumbs up here just to make sure that I don't get carried away. Let me see. Yeah, I think I'm getting thumbs up, so I'm going to continue here. All right. All right, so let's do the addition here. 1 plus 0, that's going to be 1. 0 plus 1, that's going to be 1. 1 plus 1, that's going to be 0, right? And there's a 1 here, which I'm gonna put here right now. I need to fix that every time I copy paste, the font goes to changes. Okay, so 1 plus 1, you see my mouse, you see my pointer here. 1 plus 1 is going to give me 0, this 0. And there's a 1 that goes here, this 1. And then 1 plus 1 plus 1, that's going to be 1. And then, of course, let me kind of move this a little bit to the left. And then there's going to be 1 here. Okay. Now, of course, when you add -2 to -1, you end up with -3. And I should say -3 is, again, I'm going to start with 3 here, which would be that. And then I'm going to say 1, 1, 0, 0. And that's -3. So what Anthony was thinking of is when we see a 1 that looks here, that gets here, kind of extends the most significant bit. This is the most significant bit. And this is the carry out from adding the most significant bits. And what Anthony was thinking is if we have a 1 here, maybe we can just swap the ones with 0, zeros with 1s, it would work. And in this case, clearly it doesn't work, right? If you swap those ones with zeros and vice versa, you're not going to end up with this one. So let me tell you what you need to do when this happens to make sure that the answer is correct. But maybe I should give you First, there's a question here that I need to answer. Then I can give you a few seconds to think about that. Why do we still carry the last one when 1 plus 1 plus 1? So 1 plus 1 plus 1 is 3, which looks like 1, 1. So we have a 1 here, and then there's a 1 that gets carried over. So 0 plus 1, that's 1. 1 plus 1, there's a 0, and then 1 gets carried over. And when you have 1 plus 1 plus 1, that gives you 1 in the result, and 1 gets carried over, because 1 plus 1 plus 1 is 3. That looks like 1, 1 in binary. So, all right. Do you want to guess what we need to do to make this work? You can actually guess. I'll give you just a few seconds to guess. How do we make this number look like this one? Switch the values following the MSB. You can, but that's not going to do it. It's actually simpler than that. Okay, to do with the 2 carried, it has to do something with this one. So whenever we have a 1 here, we need to do something to this to make it the correct answer. So if you go back, just to kind of go back to this one, when we added this to this, we ended up with the correct answer. And the correct answer will be, I mean, that will be the case. We will get the correct answer without doing anything when we don't have a 1 that gets carried over beyond the most significant bit. So in this case, when we added +4 to -5, we actually ended up with the correct answer. And that's because there wasn't a 1 that is here being carried over, again, extending the most significant bit. Whenever we have a 1 that gets carried over, beyond the most significant bit, then we have to do something. That thing is simply adding 1 to the result. So it's almost like you have this 1, let's take it and add it to the result. That's a good way to kind of remember what we're doing. Of course, it doesn't have to be this one. You can just add 1 to this. But if you think of it as, taking this 1 and adding it to the result, and that's going to give you, of course, this one, then that's an easy way to remember it. So let's go back to this one. Okay. So again, we added -2 to -1. We were hoping that we would end up with this one. However, we did not. But because there's a 1 that extended the most significant bit, what we could do, I'm going to actually just copy it and paste it. I'm not going to use the same exact one. I'll just use another one. I'm going to put it here. And simply what we would do is we would add this 1 to this. So 1 plus 1, there's going to be a 0 here. And there's a 1 that goes here. 1 plus 1, there's a 0. And there's a 1 that goes here. 1 plus 0, that's going to be a 1. And of course, 1 goes down here. So that's what we end up with, which is really what we want. Do you have any questions about this? So to summarize, you can do addition in 1's complement, and it will be correct if you follow this kind of minor rule. And the rule goes like that. If after adding those 2 sequences, you ended up with a carryover that extended the most significant bit, just take it and add it to the result, and you will end up with the correct answer. Very simple. If when you added the 2 sequences, you didn't end up with the most significant with a carryover that extends the most significant bit. So if there was no 1 here, there was just 0, then you don't have to do anything. It'll be the correct answer. So in that sense, 1's complement is actually better than sign magnitude, because there is a way to make addition work every single time if you just follow this simple rule. Let me pause here and see if you have any questions. Okay, I think that was great. I think I really liked what we did. I liked this example that we started with, and I liked what we have here. And you can see here, I do have another example that I'm going to post with you. I'm going to share with you, and I'm going to be posting those slides to Oaks, and you will see that it will say that this is giving us the incorrect answer. And that, of course, is because there's a 1 that's extending the most significant bit. If you do the addition, 1 plus 1, there's a 0 and there's a 1 here. 1 plus 1 plus 1, that's going to be 1 and there's a 1 here. 1 plus 1 plus 0, that's going to be 0 and there's a 1 here. 1 plus 0 plus 1, there's a 0 and there's a 1 here. So there is a 1 that's extending, again, the most significant bit as a carryover. And that goes here. And if we add it, we end up with 0, 0, 1, 1, which is the correct answer. And that's all in the slides. So when adding with 1's complement, if the carryover extends past the most significant bit, then we need to add 1 to the result. And that would work. And here you can do that home. We can do that quickly right now. But here in this case, 0 plus 1, 1, 0 plus 1, 1, 1 plus 1, 0, and there's a 1, 1 plus 1, 0, and there's a 1. So we have to take this 1 and actually add it to the result. In this case, that's going to work. We don't need to do anything. In this case, this is -7, and this is 7. And we're going to end up with all 1s, which is really the negative representation of 0. So it's a 0, which is correct. In this case, we're going to have a 1 that extends the carry, extends the most significant bit, and that's going to have to be added. So in this case here, we add 1 to the result. Here we add 1 to the result. Here we don't need to do anything. Again, you can do it home. I think I have the answers. I actually don't have the answers here, but I can add them before I post the slides. All right, do you have any questions before we move to 2's complement? And before I do that, I'm going to have to stop the recording. Okay, so I'm going to say stop recording.